All right, let's jump in.
Howdy, folks. How's it going? Awesome. I'm super excited for the workshop today. I think this is going to be really interesting. We talk, and feature stores are so popular these days, and I think it's really important to have some time to just actually work on this, get your hands on, see what it looks like to actually use a feature store for an example application. And then we can go ahead and work through it. And I'm hoping this is super interactive. I would love to get some feedback throughout this and make sure we pause and provide you with all the opportunities to learn how a feature store can work for you. But to kick things off, I just want to go through an overview of what we want to cover today. So as Sam said in the overview, today, what we're going to do is build a real-time fraud detection model. But our real goal for this is to understand what it looks like to use a feature store in the real world. And so fraud, I chose for a reason. It's one of the most common models that we hear about at Tecton that people really need the right tools to be able to get into production. It offers a whole bunch of the classic problems that lead people to come towards a feature store. Things like needing very real-time predictions, things like complicated aggregations over streaming data. And so it's a really good example for us to see how a feature store is really the perfect tool in a general sense to get a model like that into production. And so what we're actually going to step through today is first, we're going to just sort of look at data. We've got some data sources. I'll talk about them in a second. I'm just going to make a sort of high-level plan of how we can build a model to do fraud detection and sort of what we want to go do with it. Second, we're going to do a whole bunch of feature engineering. This is the core of feature store work. So we're going to actually go through, build a bunch of features on top of that raw data. I'll show you in depth what that means in Tecton in particular. But broadly, this is meant to be a high-level overview of the power of the feature store in general. Once we've gone through, built all these features, we're going to generate a training data set in Tecton. Feature stores, when done right, provide really powerful tools, not just for serving data, but also for accessing data offline and generating training data sets that are valid and don't have any skew from your served data. And so that will be a really important part to understand the training side of a feature store. Then once we've done that, we'll take that data set that we generated and actually move to a just Python environment and start building a model. This is not going to be a in-depth model building experience. We're going to just do a really high-level, simple XGBoost model. But I do want to make sure to touch on different model building environments and how a feature store can plug into them so you can sort of visualize, however you build models, how a feature store is going to work with that. Once we've trained the model, we're going to actually host that model as an endpoint. So this is one of the most popular deployment patterns we see for these real-time models, is to actually host some sort of endpoint that you can scale to meet your demand. And we're also going to create an endpoint that will retrieve features for us at serving time. Now, in reality, this is fairly automated by Tecton, but I do want to highlight that, because then the last step we're going to go through is moving that whole thing into production. And so we're going to look at just an example of what code in production looks like that's using both a feature store and a model endpoint to do inference. All right, so the data I'm going to use today is a whole bunch of synthetic transaction data that I totally ripped off from an open source project called PaySim that's been used in a Kaggle competition before. So this is super synthetic data. Downside of that is it's not going to give us a lot of insight into model performance because it's synthetic. But the upside is it's free, it's available for everybody, and no privacy concerns. And so the actual data is basically a historical log of transactions that we've come across. So this is going to be people sending money from one person to another person, along with transaction types and when those transactions happened. And you can think about that being sort of the log of a whole bunch of events that came from some sort of streaming data source like Kafka. And so in this case, I haven't actually, this isn't a simulation that's currently running and sending data over a stream. And so we're only going to be working with the batch data. But I am going to touch on how you could register that streaming data source with Tecton so that all of the features we define in the workshop today are things you could actually use against a streaming data source. And then you could bring real-time data into production with Tecton. A couple of other data sources that I've spoofed out to use for this demo. One is a whole bunch of information about users signing up. And another is the information about users like credit scores. So another thing I don't claim to be as an expert on the many ways that people do fraud, but I use these as sort of examples that resemble data sources we've heard about before from our users, that you could imagine sort of bringing on additional user or data and how easily you can use that with the feature store and fuse that together into a feature set. All right. Last thing I'm going to do is give you the world's fastest overview of what a feature store is for getting everybody on the same level here. So in particular, I'm just going to spend a second talking about Tecton's architecture, and I will make sure if anybody has questions about this to check the chat in particular at this point in time, so we make sure everybody is level on what we're expecting from a feature store. So Tecton is a cloud service. We'll install into someone's cloud account. And what that means is we exist sort of next to your data sources, and Tecton will connect to your data sources. This is where your raw data is stored, whether it's offline data, a data warehouse, a data lake, Hive tables, whatever it may be, or online Kafka or Kinesis streams. And once those data sources are registered with Tecton, you sort of have access to start defining features either from those data sources or using transformations against those data sources that will become features in the feature store itself. And so in particular, what we're going to go through today is some of the tools that Tecton has to actually build pipelines, like feature pipelines, which are transformations that define features against your raw data. And then Tecton will actually manage and run Spark jobs that will calculate the values of these features or subscribe to Kafka streams and actually land the values of features into the feature store so that we can consume them downstream. The feature store and most feature stores are actually composed of two components. One is an online feature store and one is an offline feature store. So to the user, this is transparent, but just to go through how this actually works, when a new feature value is calculated, we write it into the online feature store. And you can think of that online feature store as a place where our features are stored with low latency so they can be really quickly retrieved to do things like model inference. Offline, we're actually going to store the historical values of those features, and that's going to make it so that we can more quickly retrieve those values to do things like generating training data sets or just to explore our data. So a couple of tools we're going to touch then today to actually get data out of the feature store. One is our SDK. This runs in Python, and it's going to be the tool we're going to use to generate training data. It's just a Python SDK, so it's a whole bunch of APIs that allow you to explore the feature store, browse the raw data, and then actually potentially fuse things together into a data set. Online, we're going to touch the serving APIs that Tecton provides that make it really simple to get the inference data we need for a model out at serving time. So these are real-time endpoints that respond really quickly and get you the latest value from the online feature store. A couple other pieces that we're going to have to touch today. One thing that's unique to Tecton is the definitions of all your features. Everything that's running in the feature store is defined in a code repository. And so that code repository is going to be where you're going to actually write your feature definitions, or we're going to lump those together into feature sets. It's going to be where all of our data sources are registered. And so this is a declarative place where you say, this is everything that should be at the feature store right now. And then we provide a command line interface that you'll use to actually sync up that repository to Tecton itself. So that's all something we're going to touch on today as we build out these features. And the last thing I will talk about from a high level is a user interface that we're going to browse through that will show us our data sources that we have registered. We'll be able to actually look at the features we build, see them be materialized in real time, and preview that underlying data, and basically just provide a pane of what's actually in the feature store that we can use as we start building things out. All right, so any questions about this? As I said, I will be looking at chat. Happy to answer any questions about feature stores in general if anybody has them along the way. But without further ado, I will launch into the actual process of building this fraud model. I said on LinkedIn yesterday, I have a feeling we might set a world record here because this is going to be pretty quick, especially, we built a lot of these features ahead of time. So the upside of a feature store, it really tends to accelerate how quickly you can get things into production. So I want to start in the Tecton user interface. And what I want to go through first is the data sources that we have already defined and hooked up to Tecton. So in this case, I have data sources from a handful of different use cases. And I'm going to nail down to the ones that I have that we're going to use today that are registered about fraud detection. And so these are those data sources I told you about before: logs of transactions, logs of users that have signed up, and their credit scores. And so if we go into any one of these data sources, these basically show you the schema. It will tell you everything that you can, all of the information in columns of this table, and metadata about this, where this has been defined, that kind of thing. And so for this demo, I've already gone through the process of hooking up. In this case, these are all Hive tables. And I've gone through the process of hooking this up to make it so that we can very quickly get running here. So the next thing I'm going to do is actually hop over to a Databricks notebook in this case. And we're actually going to use the Tecton SDK to start looking at what this underlying data actually looks like. And so for each of these data sources, I've just reached out to get them from this Tecton API. And I'm just going to preview them to look at what this underlying data looks like. So we see things like the transactions are who it's from, who it's to, how much the transaction was, what type of transaction it was. We have labels in this case for the historical data of if that transaction was fraud, and a timestamp of when that occurred. I see a question in the chat about if Tecton supports unstructured data sources. As of today, the only data sources that we support are sort of your traditional table-like SQL queryable data sources. There's a different set of problems, I think, that get posed when you start dealing about unstructured things. One thing I'll touch on is a valid SQL column is strings. And so we've had some users use those to store some strings that they then embed or something like that. But in general, things like images, we don't support right now. All right, moving forward. So the other data sources we have, the signups, which is just a user ID when they signed up, their date of birth. And we have a credit score table that has user ID, some date that a credit report was run, and a credit score. Sam asked if there's a follow-on notebook or repo we can access later. Yeah, I will make sure to make that available. This notebook in particular, Databricks notebook, isn't available right now, but I will send that out, and also the other code associated with that so that everybody can look at this. Great. Okay. So the next thing I want to touch on is sort of the power of a feature store in terms of feature reuse and not necessarily having to build everything from scratch every time. And so I'm going to flip back to the web UI of Tecton, and we can spend a second going through the features that have already been defined in Tecton and see if there's anything that we can reuse without having to rebuild every single feature from scratch. And so when we first get here, we see features defined over a handful of different use cases. Things, there we have features here about ad serving, and our concern here, though, is about fraud. So what we're going to do is filter down to fraud. And what we can see is we already have defined the feature of a user's credit score. So that was just one of the raw data sources. This feature is going to be a really simple sort of select from the data source. And when we click on this, we can see the metadata about it. So we can see who made it. In this case, it was me. I made it. But if one of my teammates had, I would know who to reach out to and contact about this. We get helpful code snippets about how we can actually preview this, and we'll do that in a second. We can see information about how this data is actually being stored. So right now we can see that this data is being stored online and offline. So in both of those feature stores, a whole bunch of Spark jobs that were run to actually calculate the values of this feature and landed there, how fresh this data is, some basic statistics about the data, which I think I kicked this off this morning, so it's still probably computing these. And so this looks like a feature that we can sort of grab right away without having to redefine it and use for our model. So we'll tuck that away, and just to show what this data actually looks like, just like I could with the data source, I can preview this feature package. So in this case, I'm going to say, get this feature package about the user's credit score. I want to preview it in the range between December 14th and 21st. And so if I run this, we get a quick preview that shows sort of just like we expected. Actually, this is running right now. Once this pops out, we'll see a preview of what this feature actually looks like, and just sort of what you expect. It looks just like the batch data source. In this case, we got results from 12/15. So we're going to tuck this away for later and know that this feature that exists, user's credit score, is something that we can just plug into our data set down the line once we've built out all the other features we want. I will start, I'm going to head over to a code repository. So as I said before, every feature definition in Tecton is defined in code. And so let's flip over to that repository. And actually, the first thing we'll do is look at this credit score feature that we just previewed and see what this actually looks like in code in Tecton. And so in this repository, this credit score feature has been defined in a file. And basically what it is I've defined some SQL transformation that I want to run. In this case, I'm saying I want to run that SQL transformation against this batch data source that has users' credit scores. The transformation is really, really simple. I'm going to select basically all of the columns from that data source. And then the last step is I turn this transformation into an actual feature in Tecton. And so what this actually looks like, I take this transformation I wrote, I plug it in here, I give it a name and a description. And then the most interesting part is how I actually tell Tecton to start materializing this feature. So in this case, I will inform Tecton that it should build a data pipeline that materializes this data online, that materializes this data offline, that backfills historical data. So this is worth dwelling on. This is actually going to pre-compute the historical values of this feature back to some point in time. In this case, I'll do back to the beginning of December. We'll schedule new jobs every 7 days to comb through the repository, make sure that we pick up new values. And then we'll also set a serving TTL of 21 days in this case. So that's how long the data is valid before we want some new value to be updated to say we have a valid information on this. Looks like I got a question that says, how does the feature store keep lineage? And I will actually spend an extra second touching on that because I think it's an interesting perk of a feature store. So if we go to this, this feature, the user credit score, this is a really simple lineage, but we do see that Tecton has kept full track of where this data is coming from. In this case, it is coming from this Hive table. It's being transformed by that transformation that we just wrote, and then it's getting splayed out into the online and offline feature store. If you have more complex transformation chains, if you're coming from streaming data sources and batch sources, whatever it may be, we keep all that track too, so you'll be able to see where data is coming from, when it was transformed, and beyond that, because this code is managed by, in this case, a Git repository, you'll know exactly what the version just through Git of this transformation was at that point in time. So you can rewind to some point in time, know exactly what transformation was run against which data, and sort of back out where that data came from. Cool. I'll actually head back to the UI again. And I just want to link up what we saw about that data pipeline before to what's actually showing up here. And so we had told the data pipeline to update these values weekly, and we can see that's exactly what Tecton is telling us here, that it is scheduling jobs every week that look back for the last week and calculate new values of the features. And these jobs sort of represent that. These are jobs that have run over some period of time and are calculating new features. Cool. So this is our first feature. What we're going to go through for the next little while is the process of building out a handful of brand new features before we actually start doing our modeling. So I will head back to a notebook, and we're just going to start by basically experimenting with this data before we ever get to the code repository and try to define the feature to Tecton. So what I'm going to do is grab a small batch of, or actually that whole transactions data frame that we had. So this is that data source that was a log of historical transactions. I'm going to get that in data frame form and then start writing some Spark SQL just to build a transformation against that. In this case, I'm going to write a simple transformation that tracks how long it's been since the last transaction a single user made. And so just to step through this, we group by our user that's making a payment or some sort of transaction. And we're going to take the difference in date between now and the most recent timestamp. And so simple transformation, we're actually going to execute this query against that data source to validate what this looks like. And what we see is a whole bunch of things that are days since last. You'll notice these are all relatively high values. And that's because my batch data is from December 1st to December 31st. So these are all things that happened in December. Question in the chat, are transforms all Spark SQL, or do you have any windowing optimizations built in? Great question. So the transformations, there are two ways that you can define them in Tecton, and then I'll also touch on those windowing optimizations. So this is Spark SQL. As you said, you can also just write PySpark. If you write a PySpark transformation that gets a data frame in, outputs a data frame on the back end, and you can do basically anything you could do with PySpark, including write new UDFs, import your own packages, whatever it may be. So that's really, really flexible in terms of the types of transformations you can define. And then one thing that I will hold off on actually is talking about some of those optimizations around things like windowing. In just a second, we're going to define some features that are aggregations on our data. And I'll show off a tool that Tecton has specifically for aggregations, which are one of the most common feature types used for ML, and in particular, one of the most tricky ones that's used in fraud detection. And we'll look at what Tecton's actually doing there, some of the tools Tecton is providing to optimize those aggregations, and how that works. So in a handful of minutes, I will show that off. Another question was if the serving TTL of 21 days is the upper bound, or how does the user determine that? It's not an upper bound. It's flexible. You can set it to whatever you want. And really, this comes down to, from a modeling perspective, basically how fresh your data needs to be for you to consider it something that's worth using for modeling. So in this case, this is sort of my own imagination saying that if we haven't gotten a credit score in the last 21 days, it might have changed enough that we don't care. But in reality, for something like credit score, maybe you could say in the last 4 months is good enough. And so as long as we've gotten a value in the last 4 months, this is valid. And that just, in practice, what this is going to do is when this feature is calculated and pushed to the online store, after this period expires, instead of getting the most recent value back from the feature store, you'll get a null. And that's basically telling you, I don't know what the value of this feature is. It's been too long since we've gotten new data. It's not worth using this for modeling. It's garbage. But just for kicks, we'll actually leave this as 120 days. And we'll see that means we actually get fresh credit score data now. Okay, yeah, another question on backfilling that is a good reminder to dwell on that for a second. We'll show what this actually looks like when we generate training data, but backfilling is like one of the most crucial parts of a feature store, from my opinion. Backfilling enables you to define some feature now, and then calculate what that value of that feature would have been at some point in the past, or just fused with time travel. But in this case, we're sort of proactively defining this. And so what happens when we define this backfill to December 1st is Tecton, as soon as I create this feature, is actually going to kick off a series of Spark jobs that are going to calculate the value of this feature 7 days ago, 14 days ago, 21 days ago, 28 days ago, et cetera, back to December 1st. And that is going to be what we use offline when we generate a training data set. Instead of having to run this query against the source data to get the value at some point in time, we can just look it up from our offline feature store, save us some time, and make it really easy to retrieve a training data set. Another question is just understanding the difference between family, which we have listed here, and entity, which we have listed here. Family is just a logical grouping. Family is a tool that we use to basically differentiate between, say, use cases or teams or things like that. Entity is an actual thing in Tecton that tells us the join keys that some transformation should be associated with. So this is saying this feature is pertaining to some user. In this case, this is a pretty simple example we've built. All of the transaction, like all of our features are going to be referring to users. But you can imagine if we had something like information about merchants as another table, we might have a different entity that was referring to merchants. And then all of the features we built about merchants would be using that entity. Another question about defining features is if they can be built from several data sources. Right now that's possible, but it's not as first class of a citizen as we'd like. So we actually have a new version of the API that we're building out right now. They'll have a really first class way when you define a feature transformation to define a set of inputs that could be one or more data sources, including things like different window functions on those, different time periods and resolutions. And then you'll be able to define features against both of those that are joined together. And then with respect to missing values, we operate on whatever is in that source data. So you could write a transformation that handles missing values. You could write a Spark transformation that sets NaN values to something. We leave that up to the user, either to do upstream of Tecton or to define as one of the transformations they use in defining features in Tecton, just to decide how to handle that information. All right, I'm going to move forward to defining this new feature. So just to refresh our memory, we had built this feature, this transformation in Spark that was transforming our transactions table to tell us the date, how long it's been since a user's last transaction. And what I'm going to do is actually work on the process of taking this query that I wrote here and describing it to Tecton so that Tecton can start managing this feature and providing it to us and letting us use this data. And so just like this credit score feature, I'm actually going to define a new file or build a new file here to define this new feature in. And what we're going to do is first define the transformation itself. So in this case, this is nearly that exact same transformation that I just had over in my Spark environment, same Spark SQL. Couple of caveats that we'll walk through. So the first thing we're going to do, just like with that credit score feature, we're telling it that the input data source for this transformation is that batch log of all the transactions we have. Then the transformation, one only thing we've changed. So before, if you might remember, we had current date here as basically telling us how long from today it's been since our last transaction. Instead of current date, I'm going to use a programmatically generated date provided to us by Tecton. And this is so I can actually run this transaction a month ago, a year ago, and calculate the historical values of this feature. Really simple transformation. Tecton just passes in this information to our transformation call. So it's simple to make the jump from current date to this. But otherwise, this is that same exact query. And with respect to this code being on GitHub, it is not today. We will push this out right afterwards and make sure to share it on our public-facing Git repository. Great. Just like before, too, with that credit score feature, I'm going to take this transformation and turn it into a feature itself. And so just like before, we define a transformation with this function name. We will change or define a new feature that's using this transformation, give it a description and some name, give it that family, tag it with the same fraud detection family that we had before. And then for this feature, we're going to give it some materialization information similar to before, but with a slightly different configuration. So in this case, I'm going to say, we want to, same thing, write this feature online and offline. We want to backfill the same amount. But in this case, we're actually going to run a new job every day to calculate this feature. So the feature is how many days since the last transaction. We want to update this value every day so that we have a recent value. We're also going to provide a TTL of a day. And this is just saying, we really don't want non-fresh features being served to us. And so this is making sure that we run a new job every day to calculate values, and we only get values from current day when we query. Now that I have defined this feature, and Thomas, I will get to your question in a second about the development flow. Once I've defined this feature, I can flip over to a command line and use the Tecton command line interface to actually push this feature to Tecton. So in this case, I do Tecton. I'll plan first. This works a lot like Terraform, so it's going to basically tell me everything that's changed in my feature repository and validate that everything, like I can validate that everything makes sense and is reasonable. And so it's going to tell me a few things. I just built this new transformation, and I just built this new feature package, the days/transaction. And then it's also going to remind me that we just bumped the serving TTL on credit score from 21 days to 120 days. This looks good to me. I don't think I did anything wrong. So I'm going to Tecton apply. And we will, same thing, it will validate that everything works. And then it will provide me with a confirmation that I actually want to run this. And now Tecton has picked this up and we'll actually display this, and we'll be able to use this data. So what that actually looks like in practice, we've built this new feature, days/transaction. All of that metadata we defined is here. We can actually see that Tecton is now running a bunch of Spark jobs to calculate historical values of this feature. So we have and can monitor as this happens to know when we can start using this data. Now I want to touch on that question from Thomas about the development workflow. So you'll notice that right now I am in this prod workspace. In general, our users also have different workspaces. You can think of maybe staging or even just development workspaces for individual users. Those workspaces are generally not materializing. So they're not, when you define a new feature, we don't actually run transformations, save that data, that kind of thing. But they are a place where you can interact with Tecton, define features interactively. You can run those transformations in a more ad hoc way and validate that everything seems to work, that your definitions in Tecton seem to work. And then the workflow that I generally see is once you are confident in some feature, you can do something like create a pull request to merge your new feature into the production feature repository, and then maybe CI/CD picks that up and actually pushes it to Tecton. So in that way, it provides everybody sort of with their sandbox to work on Tecton while still having this production workspace that's materialized, that's storing data online and offline, and that is making everything available in a real production setting where you can actually then use it to, say, serve models at production time. Is there a way from the command line to wait and watch? We do have a lot of different things in the command line. So things like Tecton freshness or materialization status. So if we have materialization status of JSON class transformation, we can see all of the jobs that are running here in the command line. And yeah, obviously for the users that want a command line access to this, we try to provide all that same information. Awesome. Okay. So we did it. We defined our first new feature in Tecton. Now we are up to a impressive 2 whole features that have to do with this fraud detection use case. Let's keep moving and define a few more before we actually get to starting the modeling process. So the next thing I want to do, I promised before I would talk about how we at Tecton have special tools to help with aggregations. So the next thing we're going to do is define some aggregation features that we can use. And I'll spend a little bit of time talking about some of the optimizations that Tecton provides to make sure that those are done efficiently. Because this kind of stuff is a lot of times what blows up when you're trying to do this on your own. And I hear all the time about different teams that are struggling in particular with aggregations for their fraud detection models. So first step here, I am going to uncomment this. And so what we're going to aggregate is 2 things. I want to build 2 aggregations. One is counts of how many transactions a user has had. And another is the volume, like how much they're spending in each of these transactions or the size of each of these transactions. And so we're going to do a count of transactions and an average size of those transactions. And so to do this with Tecton's aggregation tools, all we're going to do is actually just surface those transactions and amounts. So this query that I'm going to write is actually just going to grab the user ID, a 1 indicating that there's some transaction, an amount of that transaction, and the timestamp of the transaction. And then the magic comes in the feature definition itself. This is going to look very, very similar to the features we built before, but with a couple of new things. So we're going to define, first thing is this is called an aggregate feature package in Tecton. And then piece 2 is we're going to define the aggregations that we actually want to run. So in this case, I'm going to say on that transaction column that we wrote up here, we're going to do a sum across a range of time windows, an hour, 12 hours, a day, 3 days, 7 days, some number more than that. And then we're going to do a mean on the amount column over those same windows. One other little piece. So these are sliding window aggregations. Every hour will update the value for how many, like the value of each of these for the last hour in this case. I can slim this down to something like 10 minutes, up to more than an hour. But in general, we'll do 1 hour. Setting this is more of a balance between how fresh you need your data to be, and sort of how much you actually want to calculate and rewrite new values. This is a good place to talk about streaming, because this is really where this optimization is particularly useful in the streaming case, where you have data coming across a stream and you need to do potentially long window aggregations, and that can be really complex if you have streaming data and batch data and you're fusing that all together. And so the way that streams are defined, streaming data sources are defined in Tecton, and the reason this is so useful is that when you define a streaming data source, and I'll open up a different one that we have, all you're going to do, so data sources are also defined in code in Tecton, but you're going to define a data source that registers both a stream and a batch data source. And what that means is the streaming data source is going to be some sort of payload, Kafka, Kinesis, whatever it may be. The batch data source is going to be a historical log of that stream. And then you also tell us a function that transforms from that stream, whatever that payload looks like, to the schema of that batch data source. And then once you've registered your data sources, both a stream and a batch data source, together into this virtual data source abstraction, the nice thing is you define features the exact same way against both. Same, you can use SQL, Spark SQL, just Spark. And then we intelligently apply those transformations against the streaming source or the batch source, or both if it's needed for some large aggregation. And so if I had registered, like if I actually was running this with streaming data piping into this pipeline and running transformations that way, all I would say here is run this transformation against transactions stream. Nothing else would change. And Tecton would handle running all of these same aggregations across a stream, even if it's bigger than the window of time that the stream has data, handles the windowing and all of that, and updating these values and keeping them fresh online. I got asked how feature chaining would work, and I don't have a great example open right now, but just to give you a sense, I would add another transformation, except the input for the transformation for the second one, instead of being a data source, it'd be a transformation that I already wrote, like this. And then I would get, and then I could do the same thing, write whatever transformation I have here. And it will then, I would move this to be the transformation that actually goes into the feature. And Tecton will run all these transformations in a chain, provide you with the lineage of that, and you'll be able to see that. Paul asks about the data that's lagging behind real time from an edge device, for example. And this is a great question. There is by nature, when data comes from, say, an edge device, if your goal is to send it to a Kafka stream, have it be processed, have it be landed in the feature store, and be served in Tecton, there is some delay associated with that. That said, right now, so say, this example is using Spark structured streaming. So in reality, you're not going to be able to update a value in anything lower, like reliably, than something like, say, 30 seconds. And so you could, potentially make your sliding window 30 seconds. And that would mean every 30 seconds, Tecton would write a new value for this that would have the value of how many transactions and the average transaction across these windows. And that's pretty feasible. For a lot of data you're writing, but assuming that's okay with you, that's feasible. You could also use a different stream processing engine, and we're actually working on that right now at Tecton, integrating a more real-time stream processing engine, something like, say, Flink. And that would make it so that you could actually get sub-second potentially in terms of the data availability, even for reasonable aggregations. And that's just by optimizing and windowing this stuff. It's possible to roll up these tiles in real time and get you aggregations at a real-time value. So the answer, I guess, is two parts. With Spark structured streaming, you're probably not going to get sub-second, like hyper real-time, just what happened off your edge device. One next step is the kind of transformation engine that is built just to do that. And that is something we're working on at Tecton right now too. And we'll touch on, there are use cases where that's hypercritical. And there are use cases where these windows are more appropriate too. So it really depends on the use case. And one last bit is Tecton does have the ability to define features on request time data. So instead of going through that loop of taking data, sending it to a streaming data source, landing it in Tecton, transformed, and serving it, you can just include some piece of data in your request to get serving features. And Tecton will run a transformation on that in real time. And so for simple things that are frequent, like sometimes just identity functions running on request time data, that can be a really easy solution. Awesome. So now we've defined another feature. In fact, this is going to be something like 12 different columns of features that are all of these different aggregations that we're going to run on these. I will get this running in Tecton too. So just like before, we'll Tecton apply this brand new one. And this is just, I overwrote some stuff. I made it the stream instead of the batch. Nice thing about having a CLI that tells me what I do wrong. So now that that's fixed, Tecton will again validate this, validate the actual transformations that I wrote, and we'll apply these. And again, our list of friendly fraud features is slowly growing, and we are up to three packages of features. And just to point out, we wrote these aggregates. So these are actually going to be stored in something called a feature package. And now we can see all 12 of those columns of data that we just defined by doing all of these different windows of aggregations. All right. One more feature I wanted to define for this simple example. And it's from that last data source we had. Really simple one, but this one is information about the users and when they signed up. And if you noticed back when we were looking at the data source, it also had information about their date of birth. So in this really trivial example, I'm going to build a final feature that transforms from their date of birth to their age in days at the time of some transaction. And so just like before, simple SQL, programmatically generating time. We're running against the users batch data source that has information about users who signed up for the application. And then getting stale now, very similar to before, we're going to define a feature out of it with name description. And in this case, I will schedule jobs to update every 30 days. This is an important thing to think about with the feature store. When people have a feature store, you sort of have this incredible power at your fingertips. I could schedule a new job that ran every 5 minutes to tell me if someone's age has changed. And then if I have $10 million or 10 million users, I would, 12 times a minute or 12 times an hour times 24 times 10 million users. That's how many times I would update my age feature in the online store every day. Nice thing about being flexible with this and how you define this is Tecton provides you the tools to be a little bit smarter than that. And in reality, for modeling in particular, we expect for this fraud model, knowing their age within an hour is probably not important. In fact, knowing their age within a day might not even be important. Maybe within 30 days is good enough. So we'll actually only schedule jobs every 30 days to update this value. And that should be fresh enough. And Tecton will make sure that when we generate training data, it also matches these exact same distributions. So we're not getting real-time values of someone's age. we're getting the within 30 days version. All right, last feature down before we move on to the next section of this. We can run Tecton apply one more time. See if I made any mistakes this time. Drum roll. I'd be surprised. And once this validates everything again, we can apply our new user age and days feature, and we're off. So last time we'll do this, look at my fraud features, and we're up to 4. So the features we built now are a bunch of aggregations about the transaction history for some user, information about how old they are, about how long it's been since their last transaction, and their current credit score. So I'm going to pause here, and this is what I'm going to use for my initial model. Obviously, when people actually build production fraud models, there are potentially hundreds of features. This is the kind of thing that will grow over time. Again, the upshot of the feature store is the next person that goes along and builds some model doesn't need to figure out where all the SQL is and how to run it. It's centralized here. But this is the core set of features I'm going to use for my version 0 fraud detection model. And so our next goal is going to be to take this and actually turn it into a training data set that we can use to train a model. And what I'm going to do is actually create a logical grouping of these features that in Tecton is called a feature service. And that service is going to be the same thing that provides us with training data and also provides us with serving time data. So let's do that. This is another thing that's going to be managed in code here. First thing I'm going to do is actually import all of these features that I wrote from the various files that were defined in Tecton. So we have our aggregations, credit scores, ages, everything. And then just like I created a feature before, I'm going to create a feature service now. A lot of similar stuff, a name, a description, and the payoff here. Here's all of the features I want to use. So if you'll remember, we just defined these 3 features. This feature was one that was already defined, that was just sitting around in the feature store that we can consume without having to work with it. We just call them all by name from the other places in the repository. And once I've actually created this, very simple, one last Tecton apply to build that. And this will actually provide us with the tool that we can start using to generate training data. So this shows up now. We have other services for other types of models, but this is my fraud model now. And I can click in to this feature service. This is actually providing me the endpoint I use to get data, and it has the grouping of all of the features we defined so that we know exactly what features are associated with this particular model. So let's actually start using this. Let's build a training data set. In this case, let's actually just spend a second thinking about what we expect our training data set to look like. We have a whole bunch of information, all these features, obviously we want those. What do we actually want to predict? We want to predict fraudulent transactions. So what I'm going to do is get a historical log of data that I have of a whole bunch of transactions alongside labels of if those transactions were fraud or not. And then I'm also going to include information about those transactions that's just raw data, untransformed, that I want to use for my model. And this is the kind of thing we would expect to be available at request time, things like the amount and what type of transaction it was. And so in this case, I have that same data source we were looking at before with Tecton, the transactions batch data source. And I am going to grab that as a data frame in Spark. I'm going to sort it by timestamp to get the most recent 200,000 transactions here. We're just going to select the relevant columns for me. In this case, this is the user ID, which I'm going to use to grab feature values. My label, if that data is fraud or not, or if that transaction is fraud or not. The timestamp when that transaction occurred. and then information about that transaction itself. And what I can then do with Tecton is actually turn this frame that's basically user IDs and timestamps into a fully joined together data frame of all of the values of the features that we just defined at these points in times. And so you'll notice this data frame is called events. These are transactions. I can pass this into the feature service that we just made. And Tecton will go actually grab feature values, and it will append them on to this data frame that we have, and then it will generate a training data set that we can actually use to start building models. And so in this case, when I go build a model, what I'm actually going to do is go offline to a Python environment. I'm not going to do it in Databricks. You could, obviously. And so what I'm going to do is I'm going to build this data set. I'm going to just write it to an S3 bucket in this case, clone that to my local workstation, and then we're good to go for modeling. And so that's what I do here. I transition this data frame to actually be a Spark data frame. I can write it here. I did this ahead of time so that I didn't have to stall through this, but just so people can see sort of what to expect here. First, I'll show you what this data set is going to look like when it's done writing. So once this data set's done writing, we'll load this and actually show you what it looks like. So we have a whole bunch of information about all these features that we just defined. And so flipping through, we have user's age, days since transactions, credit scores, average transaction sizes. One thing you'll notice is a lot of null values. And this is because in this case, something like the user didn't have a transaction in the last hour. So we don't have a value for what the value of that feature should have been. So we get it null. But this is the full 200,000 row data set with all of our feature values that we need to actually train a model. Now we'll write a new one just so that y'all can see what this actually looks like. This will likely take a minute because we have to actually fuse a whole bunch of 200,000 rows of data source from all over. But this will happen while we keep going. Have a question about if a feature store is useful if I don't have timestamp data. It's a really good question. We've talked to a lot of customers that are in that same boat. I would say yes, but I would also say that Tecton, as it is today, is really built for data that's moving over time. So I think there's this particular challenge for data that shifts over time, things like transactions that are occurring, users that are clicking on things on websites, because just having a log of at some point in time what data is, having a real-time ability to get a sense of if that data changes, being able to update that, it's a particularly difficult challenge. And so Tecton is really built around helping you solve that challenge with moving data. That said, I've talked to a lot of people that have come asking for a feature store that just want the ability to centrally manage their transformations, to version data sets, to be able to run the same transformations at training time and inference time. And I think in the long road, those are all problems that are reasonably tackled by something like a feature store, in terms of just providing you with a source of truth for what transformations are, how to do them, how to execute them, and providing you with a place to run those transformations. In the meanwhile, I think there are a lot of other tools out there that aren't quite a feature store that could help centralize, manage transactions, execute them. Things that come to mind is something like, say, Pachyderm right now, which is a great place that lets you define pipelines and transformations, execute them reliably as new data comes in, and have them there. Doesn't have the way that looks, and the serving layer of that's not quite the same as something like Tecton in a feature store. And over time, I would expect feature stores to evolve to be more pertinent to that specific kind of data. But in this case, I think we're really solving one of the more complex problems out there, which is when your data is moving through time and how you can keep track of that, both historically and keep live values fresh online. Awesome. So this job's almost done, but as I said, I cheated and ran things ahead of time so that I could make sure that everything was running smooth. So what I'm going to do, we wrote this to an S3 bucket. I already cloned from that S3 bucket to my local machine. And so I'm going to flip over to a local repository, and we'll go through the very simple process of actually training a model, and then we'll see what that starts to look like in production. So I'm going to flip over to Jupyter Lab, make the text a little bigger for everybody. And we will start by just loading that data set in, and we can see, just like it was up in Spark, it is here. We have all of those same features. This is all just written. So from here, I'm going to do modeling that is super simple. All of the various ML people, including myself, will be ashamed that I'm not doing anything like hyperparameter tuning or anything fancy. But in this case, only thing I'm going to do is load this data into XGBoost, into a D matrix. I'm going to do a simple train test split to actually split it into training and test data. I'm going to pick some arbitrary hyperparameters and train an XGBoost model. So this is really simple. Because this is synthetic data, I'm not going to spend a lot of time dwelling on how we can iterate and drive up the accuracy of models. And frankly, there are plenty of more talented data scientists out there that are probably watching this right now that all are plenty qualified to train improved models. And I think the focus on ML tooling is not as much to make sure we train models better than we already do, because we're pretty good at that, but it's going to be the next step. So that's what I'm going to focus on. So once this model trains, I'm going to use the lovely tool MLflow to actually manage my artifacts, to save the format of my model, and also to eventually deploy my model. And so MLflow, if you're not familiar, is an awesome tool for tracking experiments, for managing artifacts produced by experiments, and even for potentially deploying models. They have a whole bunch of built-in deployment models. And so in this case, I'm going to write this model to a local repository with MLflow. We will infer the actual signature of this model so it actually knows what data to expect at inference time. And now we've written this, we actually see this folder show up that has not just the saved weights of the model, but also important metadata about the model, and the Python environment that is needed to run it and that sort of stuff. So thank you, MLflow, for making my life easy here, because it's going to make it really simple to actually deploy this model. Piece two, where we're actually going to deploy this is AWS SageMaker, one of the easiest tools out there for deploying models, incredibly common from users that I've spoken to. Whatever you use is pretty fine here. You could easily replace SageMaker with your favorite solution, whether it's something like Selden or just KF serving, or however you're building, if you're building custom Flask endpoints, whatever it may be that's actually executing your model. But here I'll use SageMaker. One thing I ran ahead of time that you'd need to do to actually make this work on your own is built and pushed a Docker container that will actually be able to execute this code. This is really automated with MLflow. It pushes this to an ECR repository in my account, but this takes, my internet's not good enough to upload a Docker container in real time. In fact, I don't know anybody who has good enough internet to upload a Docker container in real time, so I did this ahead of time. Last piece here is the actual deployment. And this is, again, shout outs to MLflow, incredibly straightforward. I am just going to say deploy it to some app name. This is my model name, some AWS role that I imported in the hidden section above. I'm gonna have it replace any existing endpoints by this name. And we are off. It is going to push this model up to production, the artifacts, everything needed to run it. Update this endpoint, hit like with the new Docker container and everything like that. This will take a few minutes, but once it's done, we will have an endpoint basically an API endpoint sitting in AWS that we can hit with fresh data that we're going to get from the feature store and actually perform inference. So while this is going on, let's flip to the next tab I have open and just start to talk about what inference looks like when you have built your model using a feature store like we did, because this, I think, is the real payoff of something like of pretty much any feature store. And so this is a spoof application. You can imagine this running on a phone somewhere, on a data center somewhere, whatever it may be. But we have some process that's generating transactions. A transaction in this case is some amount, a person, and they are doing something with it, or in the type of transaction. So we can run this over and over. This is just some arbitrary process that's generating transactions. So it's in the real case, people are on their phones sending money around, and you have this information available right there about that transaction. And what Tecton and the feature service makes really simple is then getting all of the values of the features that we wrote right now for some specific user. And so what that looks like is Tecton provides a REST endpoint that I'm going to hit in this function call right here. This was Tecton's URL for me. This is the actual prediction endpoint that we just created, that fraud prediction service. I'm going to pass in the user ID from one of these transactions that we generated. And Tecton will get me back. Oop, I cheated. What did I do wrong? All righty. Wouldn't have been fun if we didn't have to do something fun in real time, right? All right, I'm going to stop sharing to do some debugging real fast because I have a API key up here, but I will share my screen again in just 1 second. Everybody gets to stare at my face in the meanwhile while I copy something out. Sorry about the delay. All right, let me share my screen one more time here. Go to live debugging. We should be back in business now. Great. All right, so here's that function. Of course, it was working right beforehand, but let's see what's actually happening here. Blob. That never works the first time, eh? This was expected. I should have known. This is actually the good kind of error. Cool. So what I am actually getting in this error is information that is telling me that the features that we just wrote are not yet materialized in the online store. So we are all doing this live. All of these features that I wrote are being materialized in real time. So these are all Spark jobs that are materializing this data, including credit scores. So we need to figure out which one of these isn't done materializing yet. It looks like they are. I wonder what is left. Well, let me see if we can figure out where this materialization error is coming from. All right, so we can debug this from the Spark SDK. So I'm going to grab this feature service. So before we were just grabbing things, so I'm going to do workspace.get feature service. And this will return to me an actual object I can start working with. So we have that feature service, and then we're going to build our keys, which are going to be user ID, and we'll just grab an arbitrary one to test this out. And then we can just do feature store get feature these keys. Not sure which table is not validated. I think one change that I made that I wonder if I had worked things before is this. I don't think this is the issue, but man, good old live demos. This is being recorded, yeah. So I will Tecton apply here, and hopefully we'll be able to update this. All right, so we've made a quick update that I think I might have been writing date wrong to one of our features. So I just updated this credit score feature, and hopefully we can watch this materialize. I'm going to run through the rest of this while we get this fixed and while we wait for data to materialize, just so you can get a sense of how the production application actually looks. So again, because we have a really straightforward way of retrieving feature values from Tecton, and this will get us a feature vector in real time, then we can actually just connect to that endpoint that we created in SageMaker. Still updating, but it'll be done soon. And just pass in the data from those features to that endpoint. And because these are the exact same features I used to train my model, they're in the exact same format as I used to train my model, I don't need to do any reformatting. I don't need to go to a whole bunch of different sources to actually calculate my feature values. We just pass in the exact features I used or that I got back from Tecton, and we'll be good to go to actually do inference. So I'm going to pause and let this finish materializing. If there's any audience questions, this would be a great time for that. Otherwise, I am going to also work through the final section of this workshop where I will add a new feature to this this feature service that I have. So we're going to build a new version of this model basically and show how simple it is to transition to a completely new version of a model and to build out and promote new features and improve a model in sort of real time. So I'll monitor for the chat for any user questions about anything we've gone over today. But in the meanwhile, I will also start building out another feature package that we can start using. And so the next feature that I'm going to build is going to be more aggregations, but it's going to be type aggregation. So, and we've got a couple questions coming in that I will do first. So what do you do if the user's features are not in the online feature store? I'll start there. So if your features aren't in the feature store, if you don't have any data about a specific user, you'll just get null. Tecton will tell you that it's not there. And that is something that happens because you might not have information about a user, but you probably also don't want to invoke your model on data you don't have. So Tecton will just tell you that user is not, all of the values of the features will essentially be null. Then next question, will the aggregated features be calculated in real time? And kind of is the best answer I have. So, well, actually, no. So like when the request comes in, we're not running those aggregations from that specific point in time. We are looking up the value of the last time those aggregations got wrote to the online feature store. And so, for example, if we're calculating the aggregations every 5 minutes and running them online, we'll just look that right up. If we're calculating the aggregations every 30 seconds and writing that online, we'll look that up. And so it's not at request time actually executing these aggregations. We're just looking up the most recent time we ran it, which is something we defined here. In this case, we're writing new values of these aggregations every hour. But again, you can turn this down to sub-minute-ish right now to calculate features at that cadence. And the last questions, or the next question, any plans of having Tecton feature stores or the Tecton feature store on premises? That's not in our roadmap right now. We're pretty cloud focused, and that's where we've seen sort of the most movement for people doing machine learning at this scale right now. But I would love to hear about your use case sometime and stay in touch. I'm going to head back before I continue to tackle a couple more of these questions that have come in and just see if this data has finished materializing to see if we can start using this. And it looks like some of the online has. So I'm going to see if we have data yet. Still nothing. That's okay. Then we'll keep answering questions. Next one is online feature store is much smaller than offline. And yeah, that's exactly right. It is almost like a high performance cache, just like you said. So in this case, we use something like what is actually running that you're seeing is DynamoDB. That's just a key value of the latest values of features. And so if you have a ton of historical data, it's a fraction of the size storage-wise of what's going to be stored offline. And offline is something like S3 buckets that are something just like Hive tables, like you said, not quite, but it's how, we store it actually in like the Delta Lake format. And so it's just, cold offline storage. Yeah. And then next, is there a recency tab in Tecton for feature materialization statuses, like recently started or finished notification or updates that could make debugging easier? It's a good question. So if we head over to this feature store tab, and look at the materialization for this feature in particular, we'll actually see all of these individual Spark jobs that are running. And if I click into any one of them, I get actual information about the underlying Spark job. So this is an actual job submitted to our actual Databricks cluster, and I can do all of the same debugging I could do of any Spark job that's running, making sure things are working and making sure that everything is actually getting landed. Cool. Next question, is there a choice of online stores? Yeah, so right now, the only online store that Tecton supports is Dynamo, but we are actively building towards supporting Redis as well, which is that exact trade-off that you talked of. And I think what will be really useful when we have that flexible solution is that not only will you be able to just either use something like Redis or Dynamo, but I think you'll be able to choose on a per feature level what is right and what is the right cost-effective solution for you. And so each one of these choices, and this will apply also to compute engines moving forward and things like that, will be flexible so that you can make the right decision for trading off cost, and you can switch between those decisions feature by feature or day by day to make sure that you're getting the most cost-effective but also functional way to serve your features. And so Redis is something we're working on right now. And as Tecton continues to grow and blossom, I would expect backends of storage, compute to be pluggable to meet the exact demands of individual teams and users. And then last question I see here is about what clouds we work with. Yeah, right now, Tecton is only on AWS. We'll be on GCP and Azure this year, but AWS only at the moment. Awesome. So this is materialized. Let's see if we can get lucky or if this is going to be a wash. Nope. Interesting. Another question is, does Tecton show some visibility on cost with respect to features in different stores? And right now, that's not super visible, but it's something we've heard a lot. And I just had a conversation with our CTO about this last night and some of the ways we could move forward, making it very, very, very clear to users what the cost is of individual features over time, how much, and then you can start to make value trade-offs of how fresh data is versus how accurate your models are, where you store and things like that. And I think that is certainly something to expect from the future of Tecton is really clear cost visibility, so that you can make smart decisions about what data assets are worth what to your organization. And yeah, I'm pretty excited about that, actually. Wonder if we have a caching problem with the old table that I used to have here. This is super interesting. I just, to show you the spite of doing live demos, I ran this about 20 minutes before the demo and things were working, and then here we are not getting it. So nothing like a live demo to remind you of your place in this world. So what I'm going to do just to test a theory is name this feature service differently and see if we can get lucky by materializing it separately. If not, we have some video content that can show you what this will actually look like, and I'll provide the update. But the flashy bit that you would see is just that this endpoint returns features in something like tens of milliseconds, and then you can pass those directly into the model and do inference in a really simple way. All right, so we have applied that change. Our feature service is now called V2. I will plug in that new feature service. Still no table. All right, well, I'm going to guess this isn't going to work for me today, and that's a shame, but it is what it is. As I said, online demos. All right, so we'll continue with the next piece of the demo that I wanted to walk through, which was what it looks like to, now that we have this model being serviced in production, to actually add new features to the model, and then potentially create some variants of that feature service. So we could do something like A/B testing, roll out a new version of the model, and see what that looks like. Okay, so I'm going to copy and paste this as a template because it's going to be aggregations just like before. So the features I'm going to define in this case are going to be counts of how many transactions of each different type that we have an individual user has done. And so I will just head up to my data source, and we're going to really simply copy the different types so that I don't make transcription errors. And let's do this live. So here are the different tables we want to, or the different columns we want to grab. And they are one-hot encoded, so this will all be really straightforward. So I'm going to do cache in, cache out, debit, payment, and transfer. Cool. So just like before we were counting events and amount, now we're just going to count these actual type events, and because they're one-hot encoded, they're already ones and zeros. And so we can do just like before. We're going to actually use this exact same sum aggregation that we were using before. It fits really well. In this case, we're going to sum each one of these 5 things. So I will paste this 5 times. And now we've got 5, and then we just tap in our new columns. And voila. That was really fast. So what we've done, just to recap, is I am grabbing all of the different transaction types from our raw data. And then we're defining some aggregations over them that will tell us in various time windows how many transactions of each type a user has made. I'm going to trim down to only the last, say, 72 hours and 168 hours for simplicity. So I should have done this before I copied and pasted, but Just do a smaller number of aggregations. And once we apply this, we'll have features that will tell us, and we can preview what this looks like, all this new information. So I think this is like a really clear illustration of how simple this stuff is in Tecton, because a lot of the times this is stuff that you end up having to re-engineer every time when you're doing this without a feature store in particular. And here, in the matter of like literal 2 minutes, I can define a feature that aggregates over 5 different parameters and over various time windows, and will serve this online. So I think I did it. Let's rename this stuff so that I don't get in trouble with Tecton. So this is going to be transaction type aggregate transformers, and we'll have transaction type aggregates and transaction type aggregates, and then counts of user transaction types. Still was built by me, still released in the same place. We'll call this production even. And I think everything else is good to go. So let's see if I did that right. Tecton will tell me when I go Tecton apply. It'll come through that and tell me that I did not do everything right. So let's find out exactly what went wrong here. Invalid syntax. Probably forgot a comma or something to like, yep, I deleted a bracket. Try that again. Still invalid. We will get there. Cool. And then let's see if that looks a little bit better. Just flip back and make sure that it all looks reasonable. Oh, I also didn't rename this. There we go. Redefining this. So I'm just associated this transaction with this transformation that I just built. And we will see if that works. Imported column type. All right. I didn't register this correctly as a long, so this is completely my fault this time. I can actually go into Glue and fix this, I think. I don't want to share this on live. Well, this is just data types. It's telling me that I need to change the data type. All I need to do is shift the schema of this underlying data to be a supported data type, but that will be really simple. And so I'm not going to go through that whole thing. I will see if this prediction service works yet. And if not, we will give up and call it. All right, well, not a big deal. Sometimes things don't work, but I will follow up and make sure we get out a video of this recorded, and also plan to write a solution and a blog associated with this exact walkthrough that'll come out next week. And so with that, you'll be able to find it on our blog, and you'll get all of the code that you saw here. You'll see all the features that we built, all of the code to actually train and deploy the model. And we'll also include a video that shows off what this looks like in production so that you all can see. With that, that's the workshop. I hope you all got a slightly cleaner view by seeing this of what it actually means to use a feature store to build features, to train models, and then to service them in production. One thing I will do just to actually show what this is supposed to look like because that's not going to be too hard to do, is flip over to just a different data set that we have to show you what production actually looks like. And so in this case, this is the other model that you saw inside of our Tecton cluster. It's an ad serving model. And so in this case, it's predicting if some user who's shown some ad on some website will click on that ad. And I just bring this open to show you what production looks like in that setting. And so this is very similar code to what we had in that Jupyter notebook, where we're putting the keys together that are associated with all of our features. In this case, we had features about ads, users, websites, and also ad groups. And if we pass in those keys to this different feature service that we had that was built for this model, what comes back is just a blob of the exact values of all those features at this exact point in time, so that we can pass them into a model. So this is once I would successfully debug what was going on in the one we just built today, what it would look like, and then you'd be able to pass this into your model and do inference in real time. A question in the chat about how soon Tecton is planning to support Azure. Our current goal is the second half of this year, but again, we would love to talk to you and show you a demo and talk through those timelines with the organization to see if things matched up or if there was a reason we should accelerate for some organizations. So yeah, I think tentatively we expect to roll out general availability in the second half of this year, but yeah, please reach out if you're curious, and we'd still love to talk to you about your requirements on that. I will stick around because I'd love to answer any other questions people have about Tecton in general, about feature stores, or about anything you saw today, if it makes sense. So please keep questions coming. I'll stick around for a little while, and really appreciate everybody watching today. I hope you learned something.
All right, David, awesome presentation and amazing job managing the frequently flowing chat. David is sticking around to take additional Q&A. So if you've got questions, just drop them into the chat. We'll hang out here for a few minutes.
Perfect. Thanks, Sam. Appreciate it. Question, a couple things. Okay, awesome. So how do I see feature stores for other types of data? Images, text, maybe we could merge something. Yeah, I've had this come up a few different times, and I do think there are certainly roles. And so I'm going to separate out a couple of pieces here. Images, I actually sometimes think have like the easiest path to production. So a different set of challenges for doing inference with, say, a computer vision problem. But a lot of the times the transformations you run on a raw image are relatively straightforward. You resize it, you normalize it, that kind of thing. But it's the kind of thing where you just sort of would upload an image from your whatever device is doing inference on an image, and you're pretty much good to go. Text is particularly interesting. A lot of interesting things get done that enrich text, maybe join text together with different data sources, information about the user that's generating that text, do embeddings. And I think those are interesting. Things like embedding support are something we've actually talked about and are thinking about at Tecton. And so what in practice that looks like, embeddings can be very expensive. I think we have some time to figure out. But I definitely think there's a place for, at request time, potentially embedding text, getting data about the user, piecing that all together, and being able to use that whole package to do inference. And I think a feature store plays a real role in that. Delta Lake, I'm happy to talk about. So our offline storage is done right now in S3. Delta Lake is a tool we use to version those writes and to have ACID compliance for our writes to the offline feature store. And so just an excellent tool for us on the engineering side in terms of keeping track of things. Yeah, it's a great resource and tool. Gavin asked about our data provenance and the reproducibility guarantees. Also really awesome. It's something that I didn't touch on in the demo, but so provenance goes basically as far back as Tecton's aware. If you go back to a data source, everything that transforms from that data source, every transformation that was run, when that data was written, and what those feature values were, that's all tracked with Tecton. Another feature we have, though, is something called data sets. So when you actually generate a training data set, you can save a version of that training data set. And we store that artifact. We keep track of the state of the feature repository when you generated the training data set. And we make it so that it's really, really easy to then retrieve that exact data set so you can go use it to reproduce an experiment, or maybe worse, if you're getting audited and want to know what data was used to train a model, we provide that clean history so that you have full lineage and the ability to reproduce your experiments. Another question about how this scales and does it support serverless requests? So the beauty of the feature store architecture is that it's built to scale to massive scale. And so, for example, Michelangelo at Uber was servicing millions of requests per second, built off of a similar architecture. And that's because the input compute can scale. So we're using Spark right now. That's horizontally scalable. The actual storage scales really nicely. And then the serving layer can scale horizontally too to meet your demands across the world or volume, whatever it may be. Right now, we do actually maintain consistently running servers for retrieving features. Those API endpoints are what allow us to reach really, really low latency of getting you features in real time. Depending on your infrastructure, maybe you don't need that, but for people that are doing real-time ML, generally actually having the server be ready means that your latency is really low. Does Tecton allow or compute feature correction on historical features with backfilling? How does it manage that, keeping latencies under the hood? Yeah, so this is another one where I would see imputation or correction as a potential transformation that you could define on raw data. So if your raw data is missing values, if you need to do some sort of imputing of values, you could define that as a transformation that runs, and have that be one of the transformations in your chain. And along with that, you get the same thing, which is when the transformations run, they get written online and offline, and so you still have the low latency online. You proactively can calculate those values offline, so that you have a story of your values. One other thing I'll touch on about that, which I'm reminded of, is working on a really cool data quality integration right now that will let you define bounds on data quality, monitor data quality over time, monitor it as you're serving features for things like data drift. And I think that will also be really cool. Can I explore online versus offline feature store? For sure. So the reason there are 2 layers of storage for the feature store is just to provide 2 different use cases. So online is used to do low latency storage. So we store the latest value of every feature. So if some user has, if we want to know how many ads they've clicked on in the last day, whatever the latest value of that feature is stored online so that we can retrieve that feature in real time and use it for inference. Offline, we keep a log of that feature. So how many ads did they click on in the last day, yesterday, and the day before, and the day before, and the day before. And that way, when you go generate a training data set, it doesn't happen in 100 milliseconds like it does, or less like it does online. But you can fuse together all of the different data sources in the matter of minutes to join together a data set and use it for training. And so offline is mainly used as a historical log that you can use to generate training data sets. Is there validation in the feature store? So yeah, this is really closely tied to that data quality engine that we're integrating with right now, which will allow you to set bounds on certain data quality aspects. So if you have expect some feature to be in some range, or expect some distribution, you can get alerted proactively when something changes, when that changes, so that you can look into it, figure out what's going on, and debug that issue. I mentioned dynamic features needing a batch and streaming source and a transform. Can your data quality feature detect if that transformation isn't complete? Data quality happens in one of both data sets, but isn't entirely consistent. This isn't captured in the transform. Let me think about this for a second. I'm not quite sure I fully track this. So the way that the data quality engine work isn't necessarily on actually fixing feature values or restoring them to bounds, as much as providing you with an ability to track those distributions over time and be alerted if things are changing. So if suddenly you're getting values outside of the windows you expect, suddenly you are the distribution of your data has shifted. You can see that and start working to debug it, but we don't want to inject logic around that necessarily without you knowing, because that could sort of mess with your models just as bad as the out of distribution data is. And so we really see it as a tool to proactively be able to get in the way of shifting data distributions, and then root cause it and fix it from the root cause. So some features are of more importance than others. Could building some high PRI features or use cases others in case resource constraints be allowed? Yeah, right now, we don't have any sort of first-class handling of valuing, creating value or demonstrating that or limiting which features could be made. I mean, you can limit who can write to your feature repository and who can actually, make those changes. But I would see that as sort of a business process to figure out how to prioritize these things. And there's also all kinds of trade-offs that you can make that Tecton provides you really easy tools to make. So like the example we gave in this workshop was, how often do you actually need to calculate the age of a user? And in the case of that feature, maybe the trade-off you make isn't just deleting that feature, but maybe it's just that if you can compute it less frequently, it might still be a useful signal that you can use and leverage for your model, but you can bring down the cost of it and make more room for something that maybe you need a higher resolution feature or a more fresh value of a different feature. And so I see Tecton as a useful tool just because of the flexibility we give you in how features are materialized and defined, at being able to make those trade-offs configurably from your code, so that stuff it never bites you. Language support. I suppose, are you talking about like from the interface side, foreign languages, or like language data? Yeah, I'm actually not sure what language support we've currently built in. I'd be happy to get back to you on that. I'm honestly just not sure. So I will take your information down and shoot you a message to make sure that I get back to you on that. For data sets, how do you specify a data set? That's a great question. So the way that we see a data set is it's a thing that is the result of querying the values of features. So we made a call in this demonstration that was get feature data frame, where we passed in a whole bunch of keys of users. And what came back was a data frame with all of the feature values joined on. To generate a data set, you actually just add a single argument to that call, save as, and that will generate a data set in Tecton. And so what gets saved with that, you get the actual data frame that was generated. So that's the set of data that was actually output by Tecton. You get the status of the feature store at the exact point in time that you built that data set, so you can see exactly what features were there, the metadata associated with all of that. And so then when you go to retrieve it, a couple things. So you can just grab the artifact, that's the actual data set you generated. But you can also see what the state of the feature store was, what the features were in that request, what the transformations were at that point in time in the Git repository, so that you can go about recreating sort of every individual piece of things. How do you ensure feature consistency between model development and real-time scoring? This is really like the reason in my mind that feature stores exist, is to provide you with a really clean way to define features that are the same as they are offline and online. And so what that practically looks like is when you ask for, historically, when you're generating a training data set, if you ask for the value of feature at some specific point in time, say I want to know how old some user was when they made some transaction, what you're getting is actually the value that would have been stored in the online feature store at that point in time. So it's not an exact snapshot of at that exact point in time, how old was that person? It's saying what value was stored online when you made that request. And so the nuance there is if jobs are actually only running every 30 days to calculate the age of a user, maybe the job that would have calculated their age had actually run 15 days before the time when you asked for their age because they made a transaction. And what you'll get back is the data that would have been stored online. And so in practice, what that means is your training data set is sort of generated from the same distribution. It's generated the same way that the online data was at that point in time. And it really helps make sure that there's no skew between the data used for training and serving. These are great questions. I really appreciate them, everybody. All right. I think I'm going to sign off and get some more water and let my voice cool off from 2 hours of talking. As I said, super appreciate everybody coming and checking out the workshop today. If you have any questions, don't hesitate to reach out to me or anybody at the Tecton team at our booth. We'd love to answer, work with you, help you see how a feature store could fit into your organization or team and help you move models to production. And I look forward to talking with you either at our booth or down the line. I hope you enjoy the rest of TWiMLCon and take care. Thanks, everyone.